Respected Sir, myself Maria Lepcha and I am doing my graduation from Kamrang College Namchi South Sikkim affiliated under Sikkim University. This presentation is a part of my seasonal test which carries 25 marks. The topic of my presentation is binding energy curve and stability and radioactivity. Content it includes introduction, binding energy curve, radioactivity, application or uses, and conclusion. Introduction. It is the maximum energy, that means binding energy, that would be required to disassemble the nucleus of an atom into its component part. The curve binding energy suggests a second way in which energy could be released in nuclear reaction. The lightest element like helium and hydrogen have nuclei that are less stable than heavier. Elements up to A60 thus sticking to two nucleus together to form a heavier nucleus can release energy. The key to energy production in stars lies in what nucleus physicists call the curve of binding, which is illustrated in following figures. In this figure, it is a plot between MeV, mega electrovolt, and mass number, which shows binding energy curve. The curve indicates that how stable atomic nuclei are. The higher the curve, the more stable the nucleus. The character shape in which the peak near A60 is the nuclei are most stable on the universe. The shape of this curve suggests two possibilities of converting significant amount of mass, that is fission reaction, and another one is fusion reaction. Fusion reaction from the curve of binding energy, the heaviest nuclei are the less stable than the nuclei near h equals to 60. This suggests that the energy could release if heavy nuclei split apart into smaller nuclei having mass nearer h equals to 60. This is called fission. That means in this reaction, the more energy will be released if heavy nuclei divided into small nuclei. Another fusion reaction, the curve of binding energy suggests in second way that the energy could release in nuclear reaction. The lightest element like hydrogen and helium, they are the less stable than heavier element. Thus sticking two light nuclei together to form a heavier nuclei can release energy. This process is called fusion. In this reaction, it is a second wave process that the energy is released when two light nuclei are together form a heavier nuclei. For example, light elements like hydrogen and helium. In both fusion and fission reaction, the total masses after the reaction are less than those before. The missing masses appears as energy within the amount of energy fusion Einstein equation. That mass defect, the missing masses is known as delta M, stellar energy production. Both fusion and fission reaction have the potential to convert a small amount of energy and could conveniently account for the energy source of stars. However, stars are made from light elements, mostly hydrogen and helium. They are the lightest element. Thus, fusion cannot be initiated in stars as a source of energy, but fusion is quite possible if the right condition prevails. The binding energy for a stable nucleus is always positive number for the nucleons to move apart from each other. In the theoretical nuclear physics, the nuclear binding energy is considered as a negative numbers. The stability of a complex is related to binding energy. The stability of a chemical composition, binding energy is proportional to stability because magnitude of a mass defect, both value indicate the stability of nucleus. Just a molecule is more stable. The region of increasing binding energy is followed by a region of relative stability. In the sequence of magnesium through xenon, in this region, the nucleus has become large enough that nuclear forces no longer completely extend affinity across in within. Attractive nuclear force in this region, as atomic mass increases, are nearly balanced by repelled electromagnetic forces between proton and the atomic number increases. Radioactivity. The nuclei of natural occurring heavy elements like uranium, thorium, radium, and polonium are unstable because they are heavy elements and keep on emitting spontaneous invisible rays on radiations like alpha, beta, and gamma rays are given more stable elements. They are the most stable elements. These heavy elements are called radioactivity. Uh, the property of emitting these rays is called radioactive of the element. The emitted alpha, beta, or gamma rays from unstable nuclei are collectively called ionization radiation. Depending on how the nucleus lost this excess energy, either a lower energy atoms of the same from the result or a completely different nucleus and atom can be formed. Ionization radiation. Ionization radiation means it is any type of particles like alpha and beta or electromagnetic waves like gamma that carries enough energy to ionize or remove electrons from an atom. These radiations are such high energy that when they interact with materials, they can remove electrons from the atoms in the material. This effect is the reason why ionizing radiation is hazardous to health. In ionization radiation, electrons is removed from atoms when they interact with materials with the help of high energy emitting from alpha and beta rays. Radioactivity of the radioactive, there are two types. One is natural radioactivity and another one is artificial radioactivity. Natural radioactivity means it is the process of spontaneous disintegrations of the nuclei of heavy elements with the emissions of radiation. These are the unstable nuclei found in nature. The elements whose nuclei spontaneously disintegrate are called radioactivity elements. All heavy elements above Z is equals to 82 show the phenomenon of radioactivity. The emission of the radiations change the structure of the nucleus and transform the atoms into a lighter atom. The heavy elements are unstable, therefore they disintegrate to acquire a more stable state. Since radioactivity is partially unaffected by temperature, pressure, and other conditions, we conclude that it is a nuclear property. Therefore, alpha, beta particles and gamma rays are emitted from the nucleus. It may be noted that electrons moving around the nucleus are not responsible for radioactivity. Then after comes artificial radioactivity. It is the process in which a stable, non-radioactive nucleus is changed into an unstable radioactive nucleus by bombarding it with appropriate atomic projectiles like alpha, neutron, and proton. The difference between natural and artificial radioactivity. Natural radioactivity it is a spontaneous since in natural radioactivity the nuclei of heavy atom disintegrate on their own accord forming slightly lighter and more stable nuclei and emit alpha, beta, gamma radiations, whereas in artificial radiation it is not spontaneous. It is not spontaneous since in it the nuclei of the atom have to be bombarded by fast moving particles like alpha, proton, neutron and deuteron. In natural radioactivity is uncontrolled and hence it cannot be slowed down or accelerated by any means. In artificial radioactivity can be controlled by controlling the speed of bombarding particles used for bringing about the artificial radioactivity. In nature, radioactivity is usually shown by heavy elements, and in artificial radioactivity can be induced in light elements. Unit of radioactivity. The standard unit of radioactivity is curie. C. Curie is defined as the mass of radioactive elements which produce 3.7.10 disintegrations per second. Detection and measurement of radioactivity. The radioactivity of the radioactive substances is detected and measured by instruments like Geiger-Müller counter, scintillation counter, dosimeter. These are the three instruments which is measured for the radioactivity. Here are the pictures of the instrument. Types of radioactive rays. There are the three types of radioactive rays, which are alpha rays, beta rays, and gamma rays. Alpha rays means an alpha particles is helium nucleus whose mass numbers is 4 and nuclear charge atomic number is +2. Beta decay, a particle is a fast-moving electron which is emitted from the nucleus of an atom undergoing radioactive decay. Beta decay occurs when a neutron changes into a proton and electron. Gamma decays. Gamma rays are not charged particles. They are not charged particles like alpha and beta particles. Gamma rays are electromagnetic radiation with high frequency. They have high frequency when atoms decay by emitting alpha or beta particles to form a new atom form may still have to such a much energy to be completely stable. This excess energy is emitted as a gamma rays. Gamma rays photons have energies of 1 to 10 to the 12 joule. Application or uses of binding energy and radioactivity. Binding energy, amount of energy required to separate particles from a system of particles or to disperse all the particles of the system. Binding energy is especially to subatomic particles in atomic nuclei, to electron bond to nuclei in atoms, and to join ion bond together. Application for radioactivity, sterilization of medical instruments and food. Scientific uses of radioactivity is alpha particle emitting from the radioisotopes are used for reaction. Lastly, I would like to conclude my presentation by saying that energy curve is obtained by dividing the total nuclear binding energy by the nuclear of nucleons. The binding energy of the nucleons are in the range of the electrons volt compared to 10 of the eV for atomic electron. Radioactivity is the property of some unstable atom radioactivity to spontaneously emit nuclear radiation, usually alpha beta particles, often accompanied by gamma rays. Thank you.